Okay, let's take a look at an example. Say that you're a quality control engineer at Duff Brewery, and say that you're monitoring the impurity level in parts per million of the water used in the brewing process. And say that we're focusing on a particular impurity whose median ppm we want to see is less than 2.5. Okay, so we want the median to be less than 2.5. Okay, less than implies not equality. Okay, so that must mean that less than is in the alternative. Okay, so we want tau naught to be 2.5. Okay, we want the median to be less than 2.5. Therefore, the equality statement, which is the contradiction of less than, would be greater than or equal to, and that's in the null hypothesis. Equality is always in the null, and we know that. Okay, so we go out and collect a sample of 16 observations of water for a particular period of time, and we find the levels of impurities in each one of those observations, okay, measured in ppm. Okay? And so what we want to do with the sign test is find out what are the positive deviations from 2.5, which lie above 2.5 and which lie below. Okay? And in particular, we're going to focus on the ones that lie below because we have a lower tail test. Okay? S is going to count the observations that lie below 2.5. Okay? So let's go over here and find 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? So S is 12. The number of negative values whenever we perform this calculation is 12. Okay? So now we just have to implement our Z test statistic. Okay, that's S minus 0.5 n divided by 0.5 times the square root of n. Okay, S minus 0.5 n divided by 0.5 times the square root of n. Okay, so we'll write out this Z naught test statistic. That is 12 minus 0.5 times n, that's 0.5 times 16, divided by 0.5 times the square root of 16. Okay? Whenever we work this out, we should get a value of 2. Okay? So the test statistic here is 2. Okay? So let's say we want to use the p-value approach, let's just say. So here is our z-axis, and we've got a test statistic over here of 2. Okay? And we've got an area in the upper tail. That is the p-value. Okay? Keep in mind here that even though this looks like a lower tail test, okay, the value of S is always going to be a larger value. Okay? So we're always going to reject the null up in the upper tail. Okay? So this number will be different from this number. Since this is measuring the number of negative deviations, this is not a negative number. S is not a negative number. We're not going to reject in the lower tail. This is always going to be an upper tail test. Okay? So we've got 2 up here, and we want to know what that p-value is. It's a one-tail test, so the p-value is entirely in the upper tail. Okay? So we could go to the Z table, go down to the row 2.0 over to the column 0. And we would find that that p-value, well, so in the table, technically, we're given this. We're given from 0 to the value 2. We're given this area. And if we go look that up in the Z table, we've got 0.4772. Okay? And again, we want this tail area. Okay? So that would be 0.5 minus 0.4772. That is our p-value. And that is 0.0228. Okay, so our p-value, 0.0228, pretty small p-value, certainly smaller than alpha of 0.05, not as small as alpha of 0.01. Okay, so just depending on what our alpha is, if we wanted to be 95% confident, we would absolutely reject the null. If we wanted to be 99% confident, we would not reject the null, okay, because the p-value would be larger than alpha of 0.01. Just depending on what our level of alpha is, what amount of confidence we want to have in this result, that would affect what decision we make, because this is in between 95 and 99% confidence. Okay, let's say we wanted to draw a conclusion with 95% confidence. That would be a pretty strong result right there. We would reject the null and conclude that tau is indeed less than 2.5 parts per million. Okay, the median would indeed be less than 2.5 parts per million of impurities in the water that we're using in the brewing process. Okay, again, I do want to mention that because even though this is a lower tail test, in theory it looks like a lower tail test, what we're doing is measuring a positive number of deviations. Okay, S is going to be a positive number. We're summing up the negative deviations between each observation and tau. Okay, so because we are summing up this positive number here, this is going to end up being an upper tail rejection region. Okay, if this number lies far enough away from this in the upper direction, then we can assume that tau really is less than 2.5.